Okay, some of you have asked for help on this one. This is number 7 from the Solving Quadratics review. In this one, you're actually factoring a polynomial that's not a quadratic. So if you look at this one, it's different from the quadratics that we factored, because on those, we needed, we made our x, and we tried to figure out the numbers that multiply to give you the top, add to give you the bottom. This one's different. It's already set up, it's already set up so that you can factor by groupings. That's what we're gonna do. So I'm gonna put you over here on my document. I'm using tomato soup as a document, or a camera, document camera. Okay. There we go. All right, so we're gonna factor this by grouping. So I'm gonna group the first two together, and then the last two together. And we're gonna try to find the greatest common factor between those two groups. So this group, we see that they don't share a factor from your coefficients, because it's 2 and 5. 2's not a factor of 5, so you can't factor out the 2, and then 1's not gonna be very helpful. So we're gonna factor out that common factor of x cubed that they each have. So I'm gonna factor out an x cubed, because they both at least have that, right? And if you factor that out from this term, you're gonna have a 2x remaining. If you factor out an x cubed from this term, you're only gonna have the -5 remaining. Okay, so we factored this first group. Now this one, we're gonna factor, Emmy, shh, okay. We're gonna factor out the greatest common factor between these two. So the greatest common factor would be 3. So we're gonna factor out a 3, and do you see they both have an x? So we're gonna factor out a 3x from both of those. So we have plus 3x. All right, we're gonna factor out the 3x here. 6 divided by 3 is 2, so we have 2x remaining. Remember, these should multiply to give you this. 3 times 2 does give you 6. X times x is x squared, so we're good so far. All right, then we're gonna factor out the 3x from -15. So -15 divided by 3 is -5, and then the x we factored out. So this is what we've gotten since we factored out the greatest common factor from both groups. So now you should notice that both of the groups, so this first group and the second group, have a common factor of 2x minus 5. So that's gonna factor out, we're gonna factor that out of both of them. We're gonna have 2x minus 5 that's factoring out of both of those groups. In the part that's remaining, that's gonna be the next factor. So we have x cubed plus 3x, okay? So then from there, you always try to factor down further if you can from your two groups. So this is already now a factor that's a linear factor, so it's already to a first power, so this is as far as this one's gonna go. There's no greatest common factor to factor out. All right, over here though, do you see how you can factor out from both of these terms? You could factor out an x. That's what we need to do. So I'm gonna factor this one further. So this one we just carry down. This one we're gonna factor out an x. Factor it out of this guy, you're gonna have an x squared left. Factor it out of the 3x, you're gonna have a 3 left. All right, so then you would go to this one. Is there anything that we could factor this one down to? So we know that this one is now quadratic, or you should have picked up on that because it has the squared there. So we could try to make our x here, remember it's a times c, so 1 times the 3 would be here. All right, and then the middle term, yeah. All right, the middle term is 0, so that's gonna go here. Are there two numbers that multiply to give you 3, but add to give you 0? There aren't, right? So the only numbers you could try would be 1 and 3, and it's not gonna add to give you 0. So this is as far as it goes. So your final factors would be, typically you put the binomials in the front. So we have x, 2x minus 5, and then x squared plus 3. Boom, there's your factors. You are done. So this was help again with question 7 from the quadratic review. I'm dropping cans of soup here. All right, Emmy, can you say hey since you were making so much racket? Hey, Scarlett. All right, bye guys.